Hello everyone, in this video I am going to explain how to find length of the given curve in polar coordinates. The curve is in polar coordinates, how to find the length of that curve using integration. So suppose we have a polar curve, say r is equal to f of theta. This is the equation of the curve and it has first order continuous derivative, and for theta varies from alpha to beta, and suppose p of r theta traces this curve exactly once as theta varies from alpha to beta. Then length of this particular polar curve is given by this. This is the formula to find length of this curve. L is equal to integral alpha to beta square root of r square plus dr by d theta whole square d theta. Let's take up some examples to illustrate this, how to find length of the given curve. So here we need to find length of the cardioid. Here we have to find the length of the cardioid. R is equal to 1 minus cos theta. So actually this is the curve, cardioid heart shaped along the x-axis, and theta varies. To trace this curve, theta varies from 0 to 2 pi. We can draw this particular curve. It's a heart shaped, cardioid shape, and theta varies from 0 to 2 pi. So this is given, r is equal to 1 minus cos theta, it's the equation of the curve. We know the formula. For that we need dr by d theta. So let's find dr by d theta. So differentiate this with respect to theta. So dr by d theta is nothing but derivative of 1 with respect to theta is 0 minus integral of cos theta, that is minus sin theta. Minus minus becomes plus sin theta. So dr by d theta is sin theta. Let's apply the formula. L is given by this formula, integral alpha to beta square root of r square plus dr by d theta whole square d theta. Our theta varies from 0 to 2 pi to trace this whole curve. So alpha is 0, beta is 2 pi. And r is given as 1 minus cos theta. So substitute all these things in this formula, we get square root of r is 1 minus cos theta the whole square plus dr by d theta, as we calculated here, dr by d theta is sin theta whole square, then d theta. We are integrating with respect to theta. So expand this using a minus b whole square formula. This is 1 minus cos theta whole square is nothing but 1 minus 2 into cos theta plus square of cos theta, that is cos square theta, plus this is nothing but sin square theta, and we know that cos square theta plus sin square theta is equal to 1. Here we have 1, so 1 plus 1 2, and here we have 2 minus 2 cos theta. So what we get, 2 minus 2 cos theta. We can take out this 2 common. So here we have 2 minus 2 cos theta. Here we take 2 common, what we get is 2 into 1 minus cos theta. Half angle formula we know that. Here apply the half angle formula for 1 minus cos theta. 1 minus cos theta is nothing but 2 into sin square theta by 2. 2 into 2 becomes 4. So what we get is 4 sin square theta by 2. Simplifies to square root of 2 into square root of sin square theta by 2. So it is 2 into sin theta by 2. We have to integrate this with respect to theta between the limits 0 to 2 pi. Integrate this sin theta by 2, 2 constant outside. So integral of sin theta by 2, that is minus cos theta by 2 divided by the derivative of theta by 2, that is half. Limits 0 to 2 pi. Apply the limit here. Minus we have taken outside. So and 1 by 2. 2 into 2 becomes 4. So minus 4 into, put theta is equal to 2 pi. So what we get, cos 2 pi divided by 2, that is cos pi, it's minus 1, minus lower limit cos 0, that is 1. So minus 1 minus 1 minus 2 into minus 4. So minus 4 into minus 2 becomes 8. So this is nothing but length of this cardioid. So this is 8 units. So required length of the given cardioid is 8 units. Let's take up another example. Here we have considered spiral r is equal to theta square. Theta varies from 0 to square root of 5. Similarly, we have to find dr by d theta. So r is theta square. So the derivative with respect to theta is 2 theta. This is the formula to find length of this curve. L is equal to integral alpha to beta, this limits for theta, square root of r square plus dr by d theta whole square d theta. Substitute all these things. Alpha is 0 here. The limits for theta is alpha and beta. So the lower limit is 0, upper limit is square root of 5, square root of r. R is theta square, r square is theta power 4 plus dr by d theta is 2 theta. So 2 theta whole square d theta. So simplify this. Theta power 4 plus 4 theta square. Theta square is common, we can take it outside. So square root of theta square into square root of theta square plus 4. Square root of theta square is theta. So theta into square root of theta square plus 4. To integrate this, how to integrate this? I'll just explain it here. Substitute theta square plus 4 as some other variable, say t. So theta square plus 4 is t. 2 theta d theta is nothing but dt. So theta d theta is nothing but dt by 2. So this is of the form square root of t into dt by 2. Square root of t, integral is t to the power 3 by 2 divided by 3 by 2. So the integral is half, because of dt by 2 was there. So we have taken this half outside. So t power, t means theta square plus 4, power 3 by 2 divided by 3 by 2, limits 0 to root pi. Simplifies to 2 goes off, simplifies to 1 by 3 into, put the limits for theta. Square root of 5 square, 5 plus 4, 9, square root of 9 is 3, 3 cube is 27, minus lower limit 0. Put theta is equal to 0, what we get is 4 to the power 3 by 2. So square root of 4 whole cube, that is 2 cube 8. 27 minus 8, that is into 1 by 3 into 27 minus 8 into 1 by 3 is 19 by 3. So the required length of the spiral, given spiral, is 19 by 3 units. This is how we find length in polar coordinates. I hope you like the video. Thanks for watching.